Today we're going to talk about regression. The following scatter plot shows the protein and fat amounts in grams of food sold at Burger King. If you want to get 25 grams of protein in your lunch, how much fat should you expect to consume at Burger King? You can see from this scatter plot that we have a general linear relationship. As x increases, y increases. So the question is, we need to predict what's going to happen at 25 grams. So approximately at this point right here at 25 grams, we need to figure out how much fat there's going to be. So what we need to do is find a line that best fits this data. So we will use a line to model the relationship between protein and fat and then use that information to predict what's going to happen. To find the line that best represents the data, we must draw a line. Then we take the vertical distance between the point and the line at each x value. So if we zoom in on this portion of the graph, we have a line, we have our actual y value, x and y value right here, and then we have this point that's on the line for that x value. What we're going to do is we're going to look at the distance between these 2 points. This is called residual. And the formula for residual is y minus y hat. Now, the residual is the actual y value minus the predicted y value for a particular x value. A negative residual means that the predicted value overestimates the actual value. And a positive residual means the predicted value underestimates the actual value. What we're going to do is we're going to take these distances, these residuals, we're going to square them and add them up. After we've added them up, we're going to find the one that's going to give us the smallest or the least amount of squares. This is also known as the least squares regression line, as well as the line of best fit. So the line of best fit is the line for which the sum of the squared residuals is the smallest. And you're going to write this line as y hat equals a plus bx, or you'll also see it written as y hat equals b sub o plus b sub 1 x. So how do we find that line? Here's our scatter plot. What we're going to do is we're going to add a line to this graph. I'm going to show the squares of the vertical distances, and what we need to do is we need to move this line so that we can find the line that gives us the least amount of squares. So down here in the lower left hand corner you'll see the sum of squares. So we're going to manipulate this line so that we get the smallest amount. Now at this point you can see that as I lower this portion, the sum of the squares are getting bigger. If I raise it a little bit, looks like it's getting smaller, and then at some point it's going to start getting bigger again. So to figure out where that line best fits is by taking these squares, adding them up, and finding the smallest amount. And the line that best describes this data is the one that has the sum of the squares being a minimum. And that minimum is 2,601. So the line that best fits this data is equal to 6.413 plus 0.9769x. You'll also see it written as fat equals 6.413 plus 0.9769 times the protein. Notice the little hat that's above the word fat. That symbol means predicted. So if you were to write this in English, this would be the predicted amount of fat is equal to 6.413 plus 0.9769 times the amount of protein. So how do we find the slope of the y-intercept if we don't have software to do it? To find the slope, which is b, it's equal to r, which is the correlation coefficient, times the standard deviation of the y's divided by the standard deviation of the x's. A, which represents the y-intercept, is equal to y bar minus b times x bar. And the reason we use x bar and y bar to find the y-intercept is that this point will always be on the line of best fit. And x bar and y bar represent the mean of the x values and the y values. So, some questions that you're going to be asked that deal with regression. What does the slope mean in context of the problem? The slope is 0.9769. For each additional increase of 1 gram of fat, the fat will increase by 0.9769 grams. Remember, slope is the change in y over the change in x. So it's the change in the fat amount divided by the change in the protein amount. What does the y-intercept mean in the context of this problem? The y-intercept is 6.413. At 0 grams of protein, the fat will be 6.413 grams. How much fat grams are there in a Burger King product that has 12 grams of protein? What we're going to do is we're going to plug in 12 into our equation and predict the amount of fat. Therefore, 6.413 plus 0.9769 times 12 will give me 18.1358. So that 18.1358 is the amount of grams of fat that will be in this product. How many grams of protein are there in a Burger King product that has 15 grams of fat? So here I'm giving you the y value and you need to find the x value. So we set 15 equal to 6.413 plus 0.9769 times x. We subtract the 6.413 to both sides, divide by 0.9769, and we get x equals 8.79. So that is the amount of protein in grams. BK chicken broiler has 30 grams of protein and 25 grams of fat. Does the line underestimate or overestimate the fat grams? Explain. What we need to do is we need to find y and y hat. We're given the y value, which is 25 grams of fat. To find the y hat, we need to plug in 30 for x. Solving, we get 35.72. We know the formula for residual is y minus y hat, so 25 minus 35.72 is equal to negative 10.72. Since the residual is negative, the line of best fit is overestimating the actual fat grams.